Before we dive in, a quick refresher. Peptides are short chains of amino acids. Think of them as small messengers that travel through your body, telling cells what to do. Some peptides signal for growth, others trigger healing, regulate appetite, or fight inflammation. Today, we're focusing on one of the most interesting peptides in modern research, TESAMORELIN. TESAMORELIN is a full-length analog of growth hormone-releasing hormone, known as GHRH. That means it mimics the natural signal your body uses to tell your pituitary gland to release growth hormone. Unlike shorter versions, such as sermorelin or CJC 1295, TESAMORELIN is structurally modified. A protective molecule is attached to one end, which dramatically increases its stability in the bloodstream. This modification matters more than it sounds. Most natural GHRH breaks down in just a few minutes. TESAMORELIN, by contrast, stays active in the bloodstream for about 40 minutes. That extended window is the entire reason it behaves so differently from its peptide cousins. More time circulating means more opportunity to reach tissues that other GHRH analogs simply cannot. Most GHRH peptides do just one thing. They stimulate the pituitary gland to release growth hormone, and then they break down before reaching anywhere else. Because TESAMORELIN lasts much longer, it can travel beyond the pituitary. It circulates throughout the body, where it directly interacts with growth hormone receptors located on visceral fat cells, deep inside the abdomen. Now here's where it gets interesting. Visceral fat, the deep fat that surrounds your organs, is biologically different from the subcutaneous fat just under your skin. It has a much higher density of growth hormone receptors. That makes visceral fat unusually sensitive to TESAMORELIN's extended signal, while subcutaneous fat barely reacts at all. Result is something rare in pharmacology, a targeted effect. TESAMORELIN preferentially reduces dangerous visceral fat, the kind linked to heart disease, insulin resistance, and metabolic syndrome, while mostly sparing subcutaneous fat. In clinical research, this selective reduction is what made TESAMORELIN notable. It doesn't just shrink fat, it chooses which fat to shrink. TESAMORELIN is just one example of how peptides are reshaping modern science. GLP-1 peptides, like semaglutide, are now used worldwide for weight loss and diabetes treatment. BPC 157 is studied for tissue and tendon healing. Collagen peptides appear in skincare formulations everywhere. The peptide era is here, and it's quietly changing how we think about precision therapeutics. Here's the bigger picture. By understanding a peptide's exact structure, stability, and target receptors, scientists can engineer therapies that act with surgical precision. Instead of broad effects, we get narrow, intentional ones. TESAMORELIN is a perfect demonstration of how small molecules, designed with care, can deliver outsized and specific results in the body. One important note before we wrap up. This video is for educational and research purposes only. Nothing here is medical advice. TESAMORELIN and other peptides discussed are not approved for general use without a prescription, and laboratory compounds are intended strictly for research. Always consult a licensed healthcare professional before making any health decision. Thanks for watching. If you found this useful, leave a comment with which peptide you'd like to learn about next. There's a whole world of fascinating molecules out there, and we're just getting started.